Hello everyone, welcome to the ASM classes. Myself Ankit Khandelwal, and today we are going to discuss about the topic micro operation. So before designing the control unit, we have to understand what the control unit does. Basically, control unit generates control signals for performing these micro operation. Now, we know that programs are set of instructions, and these set of instructions are stored in a sequential memory location. So if we look on a WhatsApp, now WhatsApp is an application, and the application of WhatsApp is stored in a memory. So this is the program of WhatsApp. Now using the WhatsApp, you can send videos, you can send images, you can chat with your friends. Basically that is a text. So when you are using this particular application, you are running this program, that is a set of instructions, and by using this program you are using the data which is also stored in a memory. That is, this is an image, this is a video which are stored in a memory. So the point is that the program and data are both stored in a memory. Programs are set of instructions, and these instructions are stored in a sequence of memory locations. So to perform these instructions, basically there are three major operations, that is called fetch, decode and execute. So to perform these operations, small operations are performed by the processor. These are called micro operation. And to execute these micro operation, control unit generate control signals. So if we see all this micro operation, so micro operations are the small operations to perform a major operations, and to execute these micro operations we needed control signals, and these control signals are produced by the control unit there. If we look this whole figure, this figure consists of a processor, three buses, and a memory and input and output device. So for doing this micro operation, basically these registers are involved in the particular processor. PC is your program counter, MAR is memory address register, MDR oblique MBR is memory data register or memory buffer register. In some book it is called MDR and in some it is called MBR. IR is the instruction register, GPR is your general purpose register, ALU is arithmetic and logic unit, and CU is the control unit. There are three address buses. This is address bus, data bus and the control bus, which are connected to the memory and input and output device. Now whether you are performing any operation, basically instruction, we have to first of all go to that particular memory location where that instruction is stored. So the processor will go to that particular memory location with the help of the address bus, and this address will be provided by the program counter. After that, when we will reach to that particular memory location, the content from that particular memory location through the data bus will come into the processor, and after that processor will decode that particular instruction, and then then execution will be started. So the processor will produce the control signals to perform all these operations, that is putting the value of program counter on the address bus. This is one micro operation. Then from the memory, from that particular location, the content will come into the processor, that is another micro operation. And after that, ALU will perform on the basis of decoding what that particular instruction is going to be do. All these things are done by this processor with the help of this address bus, data bus and control bus. So now let us take a look on the micro operation for the fetch operation. So we are taking an example for move A comma B, which means the content of B register are transferred to the A register. And let us now suppose B is having 08. So after execution of this instruction, the content of A will be 08. This is the final execution. But to perform this execution of the instruction move A comma B, small operations are to be performed inside the processor. So we are considering that this particular instruction is stored in a memory at location number 3000. So now the program counter will be having this particular address, that is 3000. So here in this figure, program counter is having an address 3000. By using this address, the processor will reach to this particular memory location, that is 3000, by the address bus. But before reaching to that particular address bus, the PC transfer its content to the register called memory address register. What is the need of using this memory address register? We will see it later. But from this point, you have to know that PC will transfer the address to the MAR, and MAR will hold this address till the execution of this instruction is not completed. Means 3000 will be there. Now we know that address bus is the collection of wires. So the current is flowing inside these bus. So we reach at this particular memory location, and at this memory location, what is there? Move A comma B, which is an instruction. So the first, in a first T state, that is what this T state means, all the operations are performed by the processor by a triggering, and these triggers are provided by the clock. So in the first trigger, processor will transfer the content of the PC to the memory address register. Through this memory address register, the processor will reach to that particular location, and from that location the content will be transferred to the processor. So at 3000 location we have move A comma B. So after reaching to this particular location, this instruction will come inside the processor through this data bus. Through this data bus, the content is inside the processor, that is in the block called memory buffer register or MDR. So in the second trigger, the instruction which is stored in the memory is transferred to the memory buffer register using the data bus. Now in the third instruction, or in the third step, after having this instruction in the MDR oblique MBR, the processor has to decide where this particular content has to go inside the processor. As we know that the first line of the program is an instruction, or every new line is an instruction. So this instruction will, or this content will be transferred to the instruction register there. So in the third step, or in the third trigger, that is called T3 state, the memory buffer register will transfer the content to the instruction register. Now we know that as the program is a set of instruction, so another instruction is written on the location 3001, and again to execute this instruction which is written on the 3001 location, the value of PC has to be incremented. So the value of PC will be 3001. But yet now the execution of this first instruction is not over. So as we have seen in the pipelining means overlapping of the stages. So which means that after the fetch operation, there has to be a decoding of the first instruction. So when the decoding of this first instruction is going on, fetching of second instruction will start. Fetching of second instruction means that PC has to be incremented by the value of 1. So in the T3 states, two micro operations are performed, that is, the content of MBR is transferred to the IR, and at the same instant value of PC is incremented by PC plus 1. That means the value of PC will become now 3001. Now when this value of PC will become 3001, now we will discuss why the PC transfer its value to the MAR. Now let us suppose if this address bus is directly connected to the PC. So initially the value of PC was 3000, which was put it on this address bus, and we know that when the decoding of this first instruction is going on, fetching of the second instruction take place because by the concept of pipelining. So it means before the execution, the value of PC is going to be changed. That will become 3001, and on the address bus now the address will be 3001. So which will be a wrong step. So we transfer this particular value of PC to the MAR, which holds that particular value till the execution of that first instruction is not over. So if we see all these steps once again, first of all, from the processor using the PC register, we will reach to the address location 3000. From this 3000 location, the content will come into the MBR, and in the 30 state, MBR will transfer the content to the instruction register because this from the memory instruction is coming there, and at the same instant PC will become PC plus 1, as these two steps are independent of each other. So in the same T state, if two operations are independent of each other, they can be executed there. So for fetching of an operation, basically there are three micro operations. First, the value of PC is transferred to the memory address register. By using the MAR, we reaches to that particular address location. From that address location, the content of memory is transferred to the MBR, that is memory buffer register, or MDR, memory data register. And then in the third state, the data from the MBR is transferred to the IR. So this is the three micro operations for the fetching operation there. Now let us take one example of, again, register addressing mode, which is move A comma B. So we have seen the fetching on of this particular instruction. Fetching means the content of PC is transferred to the MAR in the first T state. In the second T state, the content from the memory, that is move A comma, will be transferred to the MBR. And in the third T state, the data of MBR will be transferred to the IR. As soon as this instruction comes into the IR, decoding starts and the value of PC is incremented by the 1 there. So these are the micro operation for fetching. Decoding is done when this MBR transfer the data into the IR. Now the execution of this instruction is remaining. So the meaning of this whole instruction is transfer the content of B register to the A register. Now both A and B are the general purpose register of the processor. So IR will transfer the message to the GPR that transfer the content of B into the A register. So in the fourth state or in the fourth trigger, the content of B will be transferred to the A register. So this is the whole micro operations performed for the instruction move A comma B or for the register addressing mode. Thank you. Please subscribe my channel and give your valuable suggestions. Thank you.